Just now, we have learned different kinds of energy. We have learned mechanical energy and non-mechanical energy. For mechanical energy, we have kinetic energy equals 1 over 2 times V squared. We have learned gravitational potential energy is equal to mgh. And we have learned elastic potential energy. Okay, it relates to the material, right? First, for kinetic energy, it is related to the velocity. Okay, the faster something is, the more energy this object has. For gravitational potential energy, it relates to the vertical position h, right? Let me ask you one thing. Why do we use energy instead of velocity and height to describe the object? They are just the same thing, right? The reason why we have to learn this kind of energy is because we have one very basic law in physics, which is law of conservation of energy. It says energy can be changed from one form to another, but cannot be created or destroyed. What does that mean? That means in a closed system, the amount of energy is always fixed. Let me give you one example. This is one of the waterfalls in Taiwan. If we measure the temperature of water at the top and at the bottom, okay, the temperature of water at the top and on the bottom, you will notice the temperature of water at the bottom is higher. You may think, why this is the case? We can actually explain this by the law of conservation of energy. Okay, when the water is going down, okay, originally we have the height h, right? So there is some amount of gravitational potential energy, okay, in this level. When the water is going down, what will happen? Its own gravitational potential energy is being transferred into kinetic energy. Okay, so that's why at this moment, water will move very fast. And then when it arrives the ground, the kinetic energy will be transferred into thermal energy. So at this moment, water will stop moving because its own kinetic energy is being transferred into thermal energy. Therefore, the water at the bottom is higher than that of water on the top. Give you one more example. Exercise 3. A skateboarder of mass 55 kg moves down a curve, frictionless ramp at a height of 2 meters from rest. Part A. Find the speed of the skateboarder when he is at the end of the ramp. Okay, so first you will notice, okay, this is a frictionless ramp. Frictionless ramp. What does that mean? If there's no friction, that means there is no energy is being transferred into thermal energy, right? So let me ask you, what energy does this guy have? This guy have, first, gravitational potential energy, right? And kinetic energy. Does this guy have kinetic energy at this moment? No. Why this is the case? Because it says from the rest, okay, this guy moves down the ramp from the rest. That means there is no kinetic energy, okay, at this moment. How about when he arrived, okay, when this guy arrived to the ground? What energies does this guy have now? Does this guy have gravitational potential energy or kinetic energy? Let's think, okay? What is the height now? The height between this guy and the ground is 0 meter, right? So in this case, the gravitational potential energy will be 0. That means now at this moment, this guy won't have gravitational potential energy. Okay, so he will be left with kinetic energy only. So since the energy is fixed, we have learned law of conservation of energy. That means we can construct an equation by conservation of energy. We have initial GPE is equal to final KE. Okay, so just now we have mentioned initial KE is 0 and final GPE is 0. So we have mgh is equal to 1 over 2 times v squared. Okay, mgh is equal to 1 over 2 mv squared. Okay, so what is v? We can cancel our m, right? We can divide both sides by m. So we have v is equal to 2gh square root of 2gh. Okay, and then you just substitute the value, then you can find out the velocity. Part B. If a heavier skateboarder moves down the same ramp from the rest, how will his speed at the end be compared with that of the lighter skateboarder? Why? Okay, so this question says, okay, now this guy, it has a bigger mass. What will happen to this velocity? From this equation, we can see m can be cancelled out, right? And therefore, m is not related to the velocity. So that means, therefore, the speed of the skateboarder at the end is the same whether skateboarder is heavier or lighter. Okay. Now let's go to the next section. Suppose you push a box in 5 seconds across the floor so that the box moves. It gains 50 joules of kinetic energy, which is transferred by you. What does 50 joule mean? So 50 joule actually, it is the amount of energy you have transferred to the box. If you want to measure how fast your energy use, then how should we measure it? I have already taught this to my Form 2 students. Okay, this is actually rate, right? Just remember rate and ratio. We have learned it in Form 2. So let me ask you. Now we want to measure how fast your energy use, right? You transfer 50 joule of energy to the box. So the numerator will be 50 joule. Denominator will be the time that you have used, right? The time will be 5 seconds. So 50 joule over 5 seconds, that will be 10 joule per second. In physics, we use one quantity we call power to measure the rate of the energy you have used. So the rate at which energy transfer or work is done is called power. So what is power? Power equals energy transfer over time taken, or it is equal to work done over time taken. Okay, these two, they are the same. Work, energy transfer, and work done. Okay, they're equal. The SI unit of power is watt. Okay, so for the example just now, 50 joule over 5 seconds, that would be 10 joule per second, right? So 10 joule per second. Joule per second is actually watt. Okay, so we have new unit, 10 watt. Now let's go to the last exercise. A girl of mass 35 kilogram runs up a staircase of vertical height 2.5 meters in 4 seconds. Find the average power she developed. Take small g equals 10 meters per second squared. First, if we want to find the power, we have to find two things, right? First, the energy transfer. Second, time use. Okay, we got the time. Time is 4 seconds. Okay, how about the energy? So this girl it runs up a staircase of vertical height 2.5 meters. Okay, as this girl goes up, this girl will gain gravitational potential energy. Okay, how to calculate gravitational potential energy? Gravitational potential energy gained by the girl is equal to mass times small g times height. So that would be 35 times 10 times 2.5. That is equal to 875 joule. Therefore, the power developed by the girl is equal to 875 over time taken 4. That would be 200